My name is Kasha Alvin Sali, and we're doing machine learning project called Generative Attention-Based Mechanisms for Fake Currency Note Detection. And we came up with the most ideal model that we'll deploy, and I'll be taking you through the first parts of this presentation covering the machine learning operations, and then of course the deployment. And then my fellow colleague will come in later to talk about the remaining part. So first of all, we started off by establishing a virtual environment on our local machine, that's the PC on VS Code. Then the next step was for creating the first API key to the back end. Then after that, running it onto the terminal, and then generating the user interface using Flask. So we started off with model training and saving. Using our data set, we were able to understand and come up with these features that will be used to distinguish or classify images depending on whether they're actually fake or real currency notes. Then after that, we normalized and preprocessed the data. And the very same data we used, we developed models. At least there were like 10 models, but depending on the evaluation scores we had come up with, we decided to go the random forest algorithm just because of its robustness and then ability to handle some high dimensional data. Then after that, we trained the model on the very training data set, and we tuned the hyperparameters here and there just to come up with a good validation and training accuracy. And then after that, we evaluated the model's performance using different test data set just to make sure that the model actually generalizes well to unseen data. And after that, we're able to save the model. And then it came to the part of deployment using the saved model. Of course, we applied PyTorch, and then we had to come up with a serialization for the very saved model. Then after that, we had to integrate first KPI, as I earlier said, just to have a user interface that will allow the users to upload images. And then we hosted the app on Render. There are very many hosting sites such as Heroku, but we chose Render just because it had ease on formatting and then coming up with a user interface, and then also uploading some of these CSV files and display. Then we also applied the cross-origin resource sharing just to allow user requests from, when you're accessing the very same hosted platform, but you're using other domains. Thank you very much. My colleague will take you from here.
Once again, this is Dr. Salim. I'm here to talk about the model we deployed. We deployed random forest, though it's a traditional network, a traditional model. We had to forego the deep learning models like the CNNs, the VITs, because they were giving us no metrics compared to random forest. So it's from that basis that I come to present to you the random forest.py. That's a Python file that we created for the random forest. So this random forest, it's trained on the neural network basis to classify images as real or fake. So it uses PyTorch to build a model, and then it also uses OpenCV for image processing. Then from there, it uses Skip to extract the image features. Then from there, we had to define the dataset path. Our dataset was saved on a local machine, so in a folder called dataset, and it has 3 subfolders: training, validation, and testing. Each subfolder had a subfolder also for real and fake. Those are the classes you're seeing here, categories. Then from there, we had to extract the features using this function. And this takes an image path. If I take an image path, it has to extract the features using 2 functions, or features also. It uses the hog, which is the history of oriented gradient. As we know, all images have different gradients and the color schemes. So we use that hog what you're seeing here to get the gradients of those images. And also we had to use the color of histograms. Color of histograms, this it shows the color distributions of the images given the number of iterations that you're using, epochs for this sense. Then from there, we have to load the data set. And on loading the data set, we use loading data set. It just for it to, we use it because it helps us in data customizing the data set. And on customizing the data set, it drives us this function. This class, I mean, for current data set. This is where we customize the data set. And customizing the data set helps us in batching and reshuffling of the features in the currency. Then from there, we have to define the neural network model. The neural network model, it uses 3 convolution layers. It has FC1, FC2, and FC3. These ones basically, the FC1 is for the input. We input the image, it then goes to the intermediary level. This intermediary level pushes the image and the features extracted to the output level, and the output is a probabilistic output in form of fake and real. Then from there, we initialize our model with the correct input size. Of course, here I have to give the neurons and stuff. Then from there, it does so through a number of multiple iterations over the epochs that you give to your model. Let's say if you give it to 10 epochs, it iterates over those epochs, and in that iteration, it's computing the training loss, the var loss, and the var accuracy. That's the validation loss, validation accuracy, and the training loss. Then from there, you just call a function which is a train model that we had defined earlier on. Then you evaluate it. Evaluating the model is basically giving you the whole instance of the model. Not like here before, whereby it was giving the training loss and validation loss of each epoch. But for this case, it's just giving you the training loss for the overall model. This is the overall model evaluation. Then from there, you call your evaluate function, which you had already initialized at the beginning. Then you save your model, and of course our model, you see, it was saved also in the working directory for where this random phrase LP was also saved. Then from there, we had to integrate it with an API. An API that we use Flask. Here we did the imports for the Flask. We initialize Flask, and then a static folder. The static folder, it's basically holding the static files. It had the fav icon, which is an icon for our UI. Then from there, we define a class. The class, like I said, it has 3 convolution layers: F1, FC1, FC2, and FC3 for input, intermediate, and output. Then from there, you have to initialize the input size, because those input sizes have to be matching with what you have put in the model. So for this case, it was 8868. Then from there, you get a directory of the current script. So after that, we have to use I had forgotten how to use the cross-origin resource sharing. Of course, this one helps your model to be deployed on different domains. Let's say my laptop and someone else's laptop, I can access the model here on the UI, the deployed version on my machine, and then someone else can't access it. That's because you didn't implement the calls. So the calls will help us to integrate the system on different domains. And then from there, we have to set all this, loading the data set and stuff. Then a function to extract the features, it's also there. Then here we have to do the routing. This is the Flask routing. You define the routing. Of course, this one takes us to the home page. This is the home page of the index.html file, like you're seeing here. That's the home page using a post, because we shall be giving information to our form, like in my index.html file. Then it goes that it extracts the features, and these features are given in form of a JSON file with a prediction and a confidence interval. A confidence interval, depending if it's fake or real, depending on the probability that has been given. Then that's it. If I'm to show you my index.html for the UI, It basically has a JavaScript file to handle the on click, the buttons and stuff. On click, if you click the predict button, what should it do? Like that, and the CSS. CSS just for adding, visual, making my UI look appealing. Then from there, we have to deploy our model. We deployed our model on render. If I'm to share another screen on render, so this is the UI. This is the UI of our model. What you do, you just choose the file, and when choosing the file, you just come choose any. Let's say it's here. Images. I'm looking. Okay, let's give it this image. I know it's a fake one. We're waiting for the model's predictions. It will take some time to process because of the different internet connections in that room. So as we are waiting, that's how our model does. It's basically the UI, but then in the end, to show you the confidence interval, to show you that this is a real image and a fake image with a given confidence. So thank you for your time. Yeah.